Okay, so basically that's all you will have to know about the function of two variables up to the second degree. Basically what we did, we looked at functions of two variables, all the functions, right? And I'm summarizing, saying that we looked at linear functions, right? And we looked at them geometrically as graphs in 3 space. Those have very nice graphs being planes, and then we looked at well, the gradient being a nice description of behavior of such a function, and then those differentiable functions, linearizable functions. Well, those behave like linear at every point approximately, and you can use that to approximate things and to, well, so far to do approximations. We never went into integration. And then, of course, there are other functions that fail to be differentiable. We don't look at them in calculus. And now we made just one step towards second degree approximation, expanding our techniques. And of course, you can expand those indefinitely with the Taylor series. It's just the further you go with the Taylor series, the more terms you have, the more technical you become. There is no point of going that fast, that far, because essentially it's repetition. So the whole idea I would like to communicate is that all we do is the standard steps about anything we study. That's what calculus is about. Now, what we practiced so far for different functions, right? Functions from line to plane, functions from line to 3 space, functions from plane to line, is making these steps. Now, the next step is to go up in dimension, and that's our goal for the rest of semester. To look at a function from a plane to a plane, and then the disadvantage of that is going to be that we cannot draw a graph. The graph will be in 4-dimensional space. Right? You have to draw the domain as a plane, and you have to draw vertically a plane, which is impossible in 3 space. So there is no geometry to be in front of us. We'll have to do everything algebraically, and still bringing all the ideas without seeing them. And that's why we practiced all these ideas and looked at them, so that we know what's important and what is it that we have to bring and we can bring, and what is it that we cannot bring or should not bring. So we'll look at functions like that, and for those functions we will do the same thing. It's just the same procedure must be done without visualization, unfortunately. Well, we will visualize whatever we can at any level, but we cannot do much. But before doing that, we will have to learn some integration. And that is just an aspect of calculus that we have to study. And we will go through line integrals, maybe double integrals, triple integrals for the next v equal 2, and that will be at the end. Okay, so that's the big plan. Integration, and then functions of plane to plane. Alright, so I'll see you tomorrow.